Arcanna is an AI platform that allows security professionals to train bespoke AI models, which are neural networks, that are able to predict on new scenarios based on feedback and training performed by the analysts on top of their data and using their experience and intuition. The analysts don't have to leave their existing UI and workflows. They can just continue working as they always have, and Arcanna will collect the decisions they make, and these models will end up working autonomously after they are properly trained. From experience, it will take anywhere between 6 to 12 hours of actual work. This includes the installation, the AI job setup, the data discovery required to understand what's going on and be able to provide feedback to those models and get to see some results. So between 6 and 12 hours. Mainly there are two ways in which we integrate. It's either with a SIEM or a SOAR. Besides them, we sometimes also integrate with a ticketing system. In terms of vendor names, we work with the biggest names in the space. Some of them are CrowdStrike, Palo Alto, Elastic, Splunk, and all this information is available on the website on the integrations page. They can, and the simplest way to do that is through the MCP protocol. Arcanna has an MCP server that allows you to interact both in terms of configuration, setting up AI jobs, modifying them, and both with the decision models to send data and request decisions or even send feedback through them. So essentially the whole functionality is available via MCP, and that will essentially allow any agentic framework to interact with us. The main ones are the reduction in the workload of security analysts, because they no longer have to spend the time to monitor and investigate all the false positives in their environment. Because of this, also the response time is reduced. The analysts get to see the real alerts, the potential attacks a lot faster, thus responding a lot faster. So workload and response time are the main ones, and this would nicely blend in, reducing the risk of organization.
They respond very fast. Our decision models are generally 15 to 30 seconds, and we've actually seen in several client environments much faster than that. In fact, one of them has been 4.5 seconds compared to their previous workflow, which took about 15 minutes. It's a loaded question. The way that I look at it is we can, for simple uses of SOAR, of automation in general, you can do the things that you do in a playbook within Arcanna. You can do a lot more than that in Arcanna. We have the ability to pull in the knowledge, experience, expertise, and cross-team decisions inside Arcanna's decision models. That said, yes, you can do context enrichment. You can do threat intelligence within Arcanna's decision models.
Your data is your data. We don't send anything to the cloud. Arcanna stays on-premise or in your cloud, and all the models are trained fully locally. Arcanna is deployed on your premises or in your cloud infrastructure. We have flexible deployment types, be it a single VM or a Kubernetes cluster or even an AWS marketplace offering. You can train Arcanna models on the data of multiple customers, but also keep the data separate for compliancy purposes. You can train the Arcanna decision models on the data of an organization or multiple organizations while also keeping the data segregated. An Arcanna instance is quite lightweight. You only need a simple VM without a GPU, something like 16 cores, 64 gigs of RAM, and that should be enough for simple decision models. Arcanna offers APIs that allow you to fully manage the decision models and programmatically deploy them and train them.
Conflicting labels do not pollute the training set because we employ a consensus mechanism that takes the majority vote out of the team's decision. We make sure that the model is trained only on the data that has been collectively agreed upon with the team of experts. We do not ship pre-trained models. The reason for this being that generic or pre-trained models might miss the nuance of your threat landscape, your tech stack, or your expert's experience and expertise, and might ingest biases that we don't want in order to not hinder learning. We train a mixture of architectures ranging from CNNs and transformers that are trained in a strictly supervised manner from scratch, from the user's feedback, and we formulate the decision-making task in a multi-class classification problem.